Greetings to everyone. Thanks for joining. Thanks for being on time. My name is TJ Willits from Veolia Water Technologies, and I'll be your moderator for today's event, which is entitled Transitioning to Cold WFI, Water for Injection, Mitigating Risks and Improving Operational Efficiency. Just some technical things to go through. Obviously, you should be hearing me speak now. If you have issues with your audio throughout the presentation, you could either sign on using your audio from your computer, or if you're having issues with that, you could toggle over and select the phone call method and use a dial-in number to listen to the presentation. Everyone's microphones are muted. There's a lot of people on the line here today. The webinar is also being recorded and will be available to watch on demand after the webinar, about 24 hours from completion of the webinar. Despite everyone's microphones being muted, we want to make this opportunity as interactive as possible to discuss and ask questions to our panelists. On the right-hand side of your screen, you should see a chat box window or a question panel. Go ahead and enter your question at any time during today's broadcast, and we'll try to get to as many questions after the webinar as possible. Now, today's webinar, Transitioning to Cold WFI, is part of our larger Veolia Water Tech Talks webinar series. You can hop over to our website, veoliawatertech.com, and browse some of the other webinars we currently have scheduled. And we're always adding and updating and distributing technical content as well. So visit often and see what other webinars we might have coming up. Outside of our live webinar series, Veolia Water Tech Talks, we have all the webinars that we've done historically on demand. Again, it's at our website, veoliawatertech.com. For those in attendance for the live broadcast, you'll be receiving a PDF participation certificate that you could use for continuing education with some of the organizations that you may belong to. It'll come out about a day or so after the webinar, so be on the lookout for that PDF document. And also, your feedback is really critical to these webinars, and we want to always continue to improve them and make them as best as possible. And just for thanks, anyone who takes the survey right after the webinar, it's about a minute or two long, we'll put you in a drawing to win a $25 Amazon gift card. So right after the webinar, please just take and answer those couple questions, take that survey, and it'll help us out a lot. And before we go into the technical presentation, a little bit about Veolia Water Technologies is that we provide customers water and wastewater treatment service within 3 key pillars. That's projects, by offering specific technologies and equipment, and of course supporting them with a wide range of services. We work with multiple markets, not just pharmaceuticals, but basically every industry and municipal type market available. Specific to pharma, we partner with customers with every part of the water loop within a facility, and you can see those listed there, from clean water to utility to wastewater, and also special initiatives such as water footprint reduction. So please keep us in mind if you have any questions or concerns with those other water treatment areas. Now at this time, we're going to transition to the technical portion of today's presentation. We're very fortunate to have Ranj Rial with us here today as our panelist. Ranj has over 30 years of experience in the design, proposals, and contracting, engineering, and validation of water treatment systems. He's held positions as senior project engineer, senior proposals engineer at Veolia, and also is involved with the pharma and cosmetics industry worldwide. So at this time, I'd love to transition the webinar over to Ranj. Ranj, are you with us today?
Hi, TJ. Yes, thank you very much for that introduction, and good morning or good afternoon, wherever you are. Thank you for joining this webinar. We'll go off into the first slide that we put up here. Looking from our point of view and feedback from our customers, the key challenges from our pharmaceutical customers fall into 3 main categories: compliance and validation, dependability and risk management, and sustainable development. And we try to do with our solutions and products, we align ourselves with the compliance with international regulations for our products, and we ensure that they're all supplied with the relevant validation packs. So once these things are installed, they are tested, IQ and OQ is done and handed over accordingly with the international regulations and guidelines. And also, a lot of customers have their own internal guidelines, which we have to comply with as well, in addition to the other internationally renowned guidelines. Dependability and risk management. We look to standardize our products, so repeatability, and that makes our products more reliable and robust. All our manufacturing is done to ISO standards, particularly some of our units are built in Europe, so they're based on that and CE marking. And in addition to that, once the systems or products have been installed, there is the ongoing service of the units and the maintenance of the service. So we have tailored some packages specifically for the pharmaceutical market for preventative and predictive maintenance throughout the life cycle of the product and system on the customer's premises. And when we design our systems and some of our products, we're always engaged in looking at our energy and water footprint usage, and we look at recovery, reuse, byproduct recovery, to ensure that we can provide you with the best sustainable solution in that particular part of your manufacturing sites. And here are just some of our technologies that we have. We have over 350 proprietary technologies. The ones highlighted in yellow are more in line with compendial water systems. The other ones are more in line with wastewater and treatment and reuse, etc. But we have many solutions we can provide throughout the whole of the manufacturing site. In terms of these membrane-based systems, I mean, these are not new. These membrane-based systems have been around for many years, and I'll talk a little bit later about how the regulations have come in line to allow our products to be used in a wider framework than they already have been, in terms of just purified water, but now cold WFI as well. I mean, the Orion unit, which is an RO-EDI-based hot water sanitizable unit, has been part of our product range since 2002. In fact, it's its 20th anniversary this year. We're on the 3rd generation of the product. We've sold over 375 units globally in various segments of the market, which are listed out there. And in terms of RO-EDI-UF, which is what we're particularly looking at for the cold WFI market, which was allowed under the highly purified water guidelines of the European Pharmacopoeia, we've sold over 70 units globally since 2002. So this is a well-established, proven process that we've been providing the marketplace for over the last 20 years. When we have a look at an overall manufacturing site, I'll work from the left-hand side and work my way around the top on this. There's obviously, for the manufacturing of your compendial products, is purified water. There'll be storage and distribution systems, which we can provide as part of that. And then following on for that, you have your WFI, traditional distillation systems, and storage and distribution as well on that side. And then within the system itself, in the manufacturing side, we can look at things for recycling some of the waters there and recovering. Should it be deemed it can be done through some of the processes we can provide. And then the remaining waste will go into the wastewater treatment system, where we can provide on your waste on site, and depending what it is. In addition to that, in terms of keeping the system running over its life cycle, we can provide, as I said before, preventative and predictive maintenance contracts and service contracts throughout the whole system. And then also for emergency purposes or purposes where you may be ripping out an old system and putting in a new system to continue production, we can provide mobile water services throughout the whole system. We even have Orions available in certain parts of the world for mobile water systems in terms of providing purified water if you want to increase your production in a short space of time. Or, as I said before, if you're ripping out an existing system and upgrading during that phase, we can provide you with a mobile unit to continue your production. And as part of the preventive and predictive maintenance packages, we also offer remote monitoring and system diagnostics, so we can monitor your system throughout its life cycle and help with the predictive . and the preventative maintenance side of things as well. And also, should something go wrong, we can provide experts from around the globe who can log into that systems and do some remote analysis for you as well, and troubleshooting. Here we see a typical compendial validated water system. So going from left to right, we have the purified water generation system into a purified water tank, and then this goes around a distribution loop. In this particular case, we have a ozonated distribution loop. The other option is obviously to hot water sanitizer distribution loop in terms of keeping microbial control. And traditionally on some sites from that, this will feed the clean steam generator, should you have some usages for clean steam on your site, and also the WFI system. So the purified water can feed into your traditional distillation units, and that feeds into your WFI tank, and again distributes around the loop within the building to the point of use again. So that is your typical compendial water system. And when we look at these systems, the key is where we got those points of use to deliver compliant water and to manage the risk to your product in terms of a robust system. We ensure that for example, we provide purified water into a purified water tank at less than 0.2 microsiemens, and at a TOC of less than 100 ppb and bacteria of less than 10 CFU per mil, which then gives you a chance, if there is any pickup in the distribution system, to be well within the limits of purified water at your point of use. And this manages the risk to your product, because if that water system is not running and is not providing compliant water, you are not making your product, and that means you're losing money. I remember many years ago visiting a site in Denmark, where we asked the customer, if the water system is not running, what sort of cost is it to them in terms of production? And they'd obviously done their homework and analysis. One of the guys piped up straight away, said 16,000 euros a minute if that purified water system is not running, which is just under €1 million a minute. So managing that risk and managing it with a suitable preventive and predictive maintenance contract is very key to all of our customers for these systems. Move on. So what is water for injection? Okay, so for those of you who don't know, this is the purest grade of bulk water monographed by the pharmacopoeia, and will be expected to be used for the manufacture of parenteral, some ophthalmic and inhalation products, and for finishing steps of parenteral grade active pharmaceutical ingredients. These are things like your saline solutions, your vaccines, anything that is injected into the system and doesn't go through the stomach like pills will or liquids will, and goes directly into the bloodstream. Whether it be humans or animals, the regulations are the same on these. In terms of the regulations, the USP, United States Pharmacopoeia, and the Japanese Pharmacopoeia, which are the two common ones out there, distillation or a purification process that is equivalent or superior to distillation in the removal of chemicals and microorganisms was allowed. So the US Pharmacopoeia and the Japanese Pharmacopoeia allowed membrane systems to produce WFI water in the past. The only issue was that as Europe didn't allow this, you had to do it by distillation. Any products that were made to those guidelines, they could not sell that product into Europe. So what most manufacturing sites did was they went down the distillation unit, which allowed them to be flexible enough to sell their products in the US, Japan, or Europe, or anywhere else in the world, because they were in line with that. Now, the European Pharmacopoeia changed its regulations back in April 2017, which allowed the use of membrane systems to produce cold WFI, so it became in line with the USP and Japanese Pharmacopoeia. And in any case, in any of these systems, you should also comply that it should not contain any added substances. The system should be designed to prevent microbial contamination and formation of microbial endotoxins. So they're still got to be stainless steel. They still got to comply with the ISP regulations in terms of internal finishes, velocities in pipework, dead legs according to ASME BPE, etc., etc. And with any of these systems, they must be validated. They must come with the validation documents as part of the V diagram from GAMP, because as we know, these systems are worthless without a wheelbarrow full of documentation to tell you that the systems have been designed, manufactured, and tested in accordance with the customer's URS. And as we said before, once the systems are installed, it doesn't stop there. As these sites get continually audited by external auditors over time, correct maintenance of a purified and WFI productions unit is essential. So you must demonstrate that you're in control of your maintenance of your system, and this needs to also be documented, and these can be provided by suitable catered service contracts to do this. In terms of the water quality for WFI, those are the three main regulatory compliances in terms of water quality requirements. So you've got the European Pharmacopoeia, USP, and Japanese. In terms of conductivity, European Pharmacopoeia is a little bit tighter than purified water at 1.1 microsiem at 20 degrees. USP is the same as for purified water at 1.3 at 25 degrees, and the Japanese Pharmacopoeia at 2.1, 25 degrees. So conductivity doesn't matter too much, as we already comply with a general purified water system. Bacteria is much tighter. It's now 10 CFU per 100 mil across the board, as opposed to 100 CFU per mil. So it's much, much tighter on that. TOC is exactly the same as purified water, so it's less than 500 ppb. And the other criteria that comes into play for water for injection is endotoxins. And across the board, this must be less than 0.25 IU or EU, some people use per milliliter in the water. So that's the criteria we have to meet with our treated water at the point of use. So that's the wording from the European Pharmacopoeia when it changed it. It will allow the generation of water for injection by distillation or by a purification process that is equivalent to distillation, and it actually stipulates, such as reverse osmosis, RO, coupled with the appropriate second membrane system. So they're looking at a two-membrane system when they talk about cold WFI. So what this little animation is describing you is how traditional distillation works. Traditional distillation works on the principles of heating water up and converting it to steam, and then removing any prevailing droplets and then condensing it into WFI water. Now, when the water is made into steam, there is a mist there which contains water, and the only way bacteria and endotoxins can be transferred into the WFI water is through those water droplets. So normally what we do is have some sort of system to remove the water droplets in a distillation unit, whether this is done by gravity, centrifugal forces, or by, in this particular case, a separator or a demister within the system. And that's how a traditional distillation system works. It is based on a phase change from water to steam, removing the prevailing droplets of water, and then condensing to WFI water. Next slide, please. So the other thing the European Pharmacopoeia talks about is water for injection, how it's obtained, and this is normally by consumption laid down by the competent authority or from purified water. Now, on a lot of sites, you know, they have use for purified water anyway. So by the addition of a WFI membrane after the RO-EDI, you can produce your WFI water. So that way you don't need two systems. You don't need a pre-treatment system, which is generally maybe an RO or an RO-EDI system feeding a distillation unit. So you have a cost of a distillation unit and a cost of the pre-treatment. You can just do it with the pre-treatment, which includes RO-EDI and UF in terms of a twin membrane system. And I've got a flow diagram that will show you a system later on in this presentation. So what that means is that in terms of capital cost, it's just a small addition of the UF filter to a purified water system. So this is very cost-effective option compared to a WFI system in terms of capital cost. I had some figures I wrote down somewhere. Oh yes. So if you look at, say, for instance, an Orion unit, which is an RO-EDI UF unit as a base price, the equivalent system with an Orion and multi-effect distillation unit would be 40% more in terms of capital cost. And if you're looking at a VCD, vapor compression distillation with RO only type pre-treatment, then you're looking at about 43% more expensive in terms to a RO, EDI, UF system or Orion system. So straight away, you're saving on capital costs in terms of the systems. So if we look at membrane-based WFI systems, the benefits are smaller footprint, lower life cycle cost, they're more energy efficient, and we'll talk about the energy a bit later on, and don't require a complex system design, i.e. you don't need additional distillation, shall we say. The perceived risks with these systems were that cold systems can lead to formation of biofilms, and these are very difficult to remove, especially when you try to chemical sanitize those systems. But what we have now, and what we have done for the last 20 years with things like the Orion product, is we have hot water sanitizable RO membranes. These prevent biofilm and microbiofilm growth on the RO membranes with regular hot water sanitization above 80 degrees. So similar to a distribution system, we raise the water temperature to above 80 degrees, hold it for an hour, and then cool it down. And this prevents the buildup of microbes and the risk of biofilms being produced on these units, and keeps them running very sweetly indeed in terms of providing the required water from the outlet in terms of the international regulations for water quality. So we all know distillation techniques have traditionally been considered. We consider them less risky because they run hot and we convert the water to steam and condensed than traditional RO systems. And the biggest reason was because of these biofilms. But we now know that hot water sanitizable membrane systems can control the biofilm buildup on these units. And we can also hot water sanitize not only the RO, EDI and the UF membranes, but also the pre-treatment in terms of softening can also be hot water sanitized. So further mitigating any risk to the treated water quality. And with adequate monitoring control, it can also be low risk. You can add in things like additional TOC monitoring straight after the generation system rather than just in the distribution loop. And also on these systems, you have lower OPEX for an RO-based system than a distillation system, especially as no steam is required to continually change the phase of water to steam. And just to give you an indication on that sort of utility usage, I mean, if you look at converting 1 litre of water at 25 degrees steam, you're using about 2,700 kilojoules of energy. Now, even if you used a cold WFI system and you had to heat the water up for the distribution loop to above 80 to 85 degrees, the energy needed to raise 1 litre of water from 15 degrees to 85 is only 294 kilojoules. So that's 11% of the energy required to converting water to steam, because there's a lot of energy required to change that phase. So you can see how much of an OPEX saving you can have in terms of a cold WFI system. Next slide, please. Oh, there we go. Okay, and in terms of the Orion unit, this is a multi-technology unit. It's skid mounted, comprising of the base unit of softening RO and ZDI, and we have a range of options which include pre and post UV and UF and filtration degassing depending on your raw water. It meets the quality standards of all the regulations of USP, EP and JP, and for cold WFI with the additional of the final UF unit. Compliant with the FDA, CGMP and GAMP in terms of documentation, etc. Also, it's designed in accordance with the current ISP guidelines for water and steam. And as I said before, these come complete with a validation pack, and they are factory acceptance tested as well before they're shipped out to a site. And they're all ready for once installed to go through your PQs on site. In terms of size of unit, these units are designed from 0.5 meter cubed an hour or 500 liters an hour up to 20 meter cubed an hour. My apologies, I should have converted that to US gallons for you guys. Yeah, so we can go to quite big units in terms of flow rates from standard designs. Here's a quick comparison for a 4 meter cubed an hour WFI unit, showing you the cost of wastewater, feedwater, heat, and annual cost. So I mean, in terms of pictorially, you can see from the right-hand side the RO, EDI, and UF is clearly lower on OPEX costs for a 4 meter cubed an hour WFI unit. So it just reiterates what I was saying earlier about the cost and the amount of utilities it uses. And the big usage is certainly on the VCD and MEDs is certainly the steam. And on VCD, you also have the electricity for the compressor as well, running continuously. Next slide, please. We talked about compliance and we've talked about the technologies. The other thing we talk about, the European Pharmaceutical states about relaxing the regulations on this. That correct operation monitoring and maintenance system is essential, and also the validation procedures must be followed. You know, regular monitoring of TOC and microbial sampling, etc., just to make sure that unit is producing quantity and quality of water. So as I said before, the units are completely hot water sanitizable, certainly the RO, EDI, and the UF as standard, with the option of the softeners also being hot water sanitizable. In terms of how we hot water sanitize, we can do it via electrically heating or steam coil, which is inside the multi-purpose tank, which is on the skid. You see on the bottom screw or bottom picture on the left-hand side. Also, within these units, in terms of CIP cleaning, you don't need an additional CIP rig as you would do in some systems for RO, EDI. It can all be done within the skid using that multi-purpose tank to put the chemicals into the system, and then we have 3 different cycles we can do for RO cleans or EDI cleans, etc., depending what needs cleaning. The other thing we provide is reduced water to discharge as part of the sustainability bit. So when the systems are making up to a purified water tank, when there is no demand, the system is in recycle. We recover the drain water from the RO. Traditionally, this was a problem because the water would heat up due to the high pressure pump on the RO. And what we've done is and we'll try it a bit later, is introduce a cooling exchanger to manage that heat buildup. That way we can recover pretty much all the water during the recycle phase. So if you're running a 16-hour shift and you're in recycle for 8 hours, during that 8 hours, you would normally send at least 10% of water down the drain. You can recover that, and that way your water footprint is reduced. The other option we have is built into the skid is an integrated recovery RO. That reduces your concentrate to drain by 50%. And that integrated RO is also part of the hot water sanitizable cycle within the system as well. So again, during the service cycle, we're also looking at reducing the amount of water you throw down the drain. We have options for ultrafiltration on the outlet and TOC monitoring for cold WFI. And these units, as we say, have been around for about 20 years. So they are robust, they're reliable, and none of you guys would be guinea pigs in taking this technology on board with a new type of system. Slide, please. So here we have a flow schematic of a typical RO EDI system. This particular flow schematic also includes a load of options which may be required due to different raw waters from around the world. So if I go from the left-hand side, we have softeners in series, first and second softener. That way provides you with a very low hardness on the outlet, because hardness has to be managed, as any breakthrough of hardness through the RO membrane onto the CEDI will irreversibly damage the CEDI. So we manage that way up front using softeners in series. There's a sodium metabisulfite dosing set there. That's an option should you have high chlorine, to remove the free chlorine, because you need to remove the free chlorine as this attacks the RO membrane, and also again will irreversibly damage the CEDI unit further down. Then we have a 5 micron filter, and then some customers ask for a pre-treatment UV to manage microbial growth after the softeners or the pre-treatment before the tank. So that's an option again. It's not mandatory, but some people prefer to have that up front. And maybe on a WFI system, you may go down that route just to give you added security up front. And then the water goes into that multi-purpose tank, and at the bottom it has either an electrical heater or a steam coil for the hot water sanitization cycle. Then from the bottom of that vessel, the water goes around, and I'll start off with the bigger pump there, the RO high pressure pump, which feeds the RO units there. You'll see on this unit we have a recovery RO, which is the bottom module on the RO, and the concentrate from that comes down at the bottom and through a RO recovery concentrate pump, which boosts the water back into the feed line. So we're recovering from the RO there as well. The permeate from the main RO then flows through to the CDI, but it may need degassing up front if you have some sort of CO2 issue, depending on your RO feed water. If you have, say, high alkalinity and low pH, then you will may well generate additional CO2, which adds as a load onto the CDI. So we remove these so the CDI runs more in its nominal flow and operating parameters. So after the CDI, we have the option for the UF for cold WFI. We also have an option for UV for some customers for normal purified water, but in this case we'll talk about the UF. Then from the UF, this goes up to a three-way valve which fits on top of the WFI or purified water tank and fills it when required, and if the tank is full, it recycles back to the multi-purpose tank. Just on the reject line from the bottom RO module there, you can see flows along to the right and up, and we have a pH dosing set in there in order to raise the pH if we have issues with high CO2 levels or with things like silica. We can also adjust the pH on the concentrate line in the tank there. And there you see the cooling exchanger, which we use for recovering the water during recycle and keeping the temperature of the unit within specification, so you don't get any microbial growth in the system. So, and on the outlet line there, you see some monitoring, you see temperature, you see conductivity, and also the option of having the TOC monitor on the outlet after the UV or UF as a final polisher. Next slide, please. One of the questions we got asked by one of our customers early on when we were going through this was a reference about the plastics and the materials used for the UF membranes. And we had these sent off to a laboratory and got them Class 6 tested. So with our unit and with those UF modules, you'll get the Class 6 tested certification to go with it. Again, this just mitigates any risk to the system and shows that you're in control, and you can demonstrate this to any auditors that may come in and audit the system. So, we have decisions to be made. The choice of WFI production method is ultimately about finding the correct balance between risk and cost. And that will differ from customer to customer on these things. We're sometimes a little bit conservative about changing from one technology to another. We don't want to be the first ones. We have got systems out there that have installed for cold WFI. And I sometimes compare this to the automotive market where, we've been running for cars on fossil fuel for years. And who would have thought, I never thought 5, 6, 7, 8 years ago that I'd be looking as my next car to be a hybrid or electric. But here we are, we're going to change over to electric cars. And that's mainly based around sustainability and cost again. So I think in this market at the moment, we're running both products. But I don't think as customers we should be afraid if we want to look at cold WFI and the advantage it has in terms of OPEX and CAPEX compared to traditional hot water sanitizer, hot water distillation systems. Next slide, please. So these products, cold WFI is a viable option now. These products are available now. We have installed them over the past few years with customers on site. Everybody has a choice. You can go one way or the other in terms of what product you want, but there is a slow movement to at least looking at the viability of putting in a cold WFI system because of its OPEX and CAPEX advantages, lower footprint, and these are now quite robust technologies compared to how they were maybe 20, 30 years ago in terms of RO membrane usages in this market. So thank you very much listening to me. Just to add on the end here, we have a we've written a pharmaceutical pure water guide, which is available free to anybody who wants it. If you can just go onto the website there, the veoliawatertech.com website, and you can download this pure water guide, which goes through all aspects of a pharmaceutical system, from pre-treatment to post-treatment to monitoring, etc. And hopefully it helps you with understanding these products and markets.
Okay, Raj, thanks so much for sharing all that experience and knowledge with us. At this time, we're going to transition to our question and answer part of today's presentation. We have a handful of questions already submitted. And just a reminder, on the right-hand side of your screen there, you should see a questions panel. And if you want, you could enter in a short question there, and we'll try to get to as many as possible. One initial question that we got here, Raj, was, it says, do you get rouging in cold WFI systems? Can you share any experience about that?
Yeah, I mean, that's an interesting question. Rouging is always an interesting question, whether it be hot or cold. I mean, traditionally, in hot WFI systems and hot loops, rouging is quite prevalent, and it sort of comes up quite quickly. I've seen systems that are derouged every year or every 2 years. They may derouge their systems. In cold systems, you tend to are less frequent. They do come in, but may take a few years, maybe 4 or 5 years, maybe even longer in some cases. But obviously, if you're running a cold WFI system with a cold distribution loop, then you are less likely to get rouging so soon. You know, it'll be a longer period before rouging should appear. But any site that has any issues, or certainly with hot WFI systems, there should be some sort of maintenance or SOP in place to check for rouging, certainly in hot systems every year, maybe on cold systems every 2 years, where you may open up some part of the system, maybe do a swab color test to check on rouging. You know, but it depends on a lot of other parameters as well. Quality of stainless steel, the polish, the quality of the welding can also have an effect on this. So hopefully that answers that question.
Great. Another question we got is in relation to the distribution loop, and it says, with cold WFI, do I need to run the distribution loop hot, or can I run it cold?
Right, okay, yeah, good question. I mean, traditionally on distillation systems, most loops run hot because the distiller will produce the water hot, but in some cases you can have, some people have had cold loops where they've had a cooling exchanger on the back end of the WFI unit to produce water going in at ambient temperature into a tank around the distribution loop, or they may just have a cold WFI requirement at a point of use where they've had local chillers or coolers at the point of use. So with a cold WFI unit, you can run it either way. It doesn't matter. You can run the loop at hot. It just means that after the generation system on the makeup to the tank, you put in a once-through heat exchanger with some controls, so you can run the water into the tank at 85, 90 degrees, so you can run the loop hot as you would do in a traditional system, or you can go in ambient temperature and run the loop cold. It really depends on your processes at the point of use and what temperature the water is required at that point. But in terms of design, you can do either or. Your hands aren't tied to one system or the other.
Great. While we're on the subject of the loop, the distribution loop, someone who attended asked, how do you monitor the loop, whether it be ozone or hot?
Oh, in terms of sanitization, you mean?
I assume it's monitoring the quality of the water throughout the distribution loop.
Well, the distribution loop, like you would do on a WFI, traditional WFI loop, you would have your conductivity, you would have your TOC monitoring in the loop, and you would do your bacterial testing from your sampling valves. It's no different to a cold WFI store and distribution loop. You would do the same with that as well. And in terms of sanitization is the difference, because a hot loop running above 65 degrees is considered to be self-sanitizing. If you're running a cold loop, then you've got to have some sort of sanitization procedure, whether it be hot or whether you use ozone within the system.
Great. Another similar question was it seems to be there's some concern within the biopharma industry that ozone could affect the viability within the cells that are used in the process of manufacturing. Can you discuss a little bit about if you heard anything like this, or if there's other alternatives to ozone?
Yeah, I have heard. Yeah, I have heard of this in some parts of the world. Certainly in France and Spain, they see it as a little bit of a concern. In those particular cases, what we have done is what we call a overheating sterilization process in the loop. So you're traditionally doing hot water sterilization, but you can also take the loop and the WFI tank up to 1 bar, which means, i.e. pressurized loop, which means that the water is at 121 degrees as a sterilization cycle to mitigate any risk like that, where people are a bit apprehensive about using ozone for this process. But we've seen customers use both ozone and hot water sanitizing, and also sterilizing at 121 degrees at 1 bar. So there are means and ways of managing that microbial growth in your loop other ways than just ozone.
Okay, this is a question related to cost comparisons related to energy here. And the person asked, is RO EDI plus UF, comparing that with hot storage versus cold storage and ozonization. So can you talk about the comparison between those two methods?
In terms of OPEX or CAPEX, are we talking for both?
Energy costs,
probably both. Energy costs, certainly with a cold WFI unit, energy costs will always be lower, even if you're running the distribution loop, if you're running it hot, because as I said before, in a distillation unit, you are changing the phase of the water to steam and then condensing, and there's an enormous amount of energy needed to change water to steam, to do that phase change. As I said, for 1 liter of water at 25 degrees to change it to steam requires 2,700 kilojoules. To heat water up to 85 degrees from 15 degrees, just the water, is 294 kilojoules. So it's about 11% of the energy used to require for distillation. So that means that with cold WFI, you can heat the water up even after the generation system into the distribution storage tank and the loop, and you will still be using less energy compared to a conventional distillation unit in terms of OPEX. And your CAPEX saving is there anyway, because you're only providing RO EDI with a UF. You don't need the additional distillation equipment, so you're saving on that. So on both accounts, in terms of OPEX and capital costs, it's a lot better than traditional distillation, shall we say, with pretreatment.
Great.
Hope that answers that.
Another question that we have here, it says, isn't RO-EDI or double membrane systems better for small production volume, such as under 50 gallons per minute, while distillation is better suited for larger volumes? Can you comment on that?
I don't think it matters. I think the way the water is produced doesn't really matter. I mean, as I say, you know, we've got units that do 20,000 liters an hour. I don't know what that is in GPM, so excuse me for that. And the biggest units we've probably put in WFI wise have probably been 13, 15 meter cubed an hour in terms of a WFI unit. So I don't think it matters. I mean, at the end of the day, either way, you can use RO-EDI for large flows as well as small flows from our point of view. The flow rates don't really come into it. I mean, distillation units, when you get to those large flows, they're huge, and traditionally you're likely to only go to a vapor compression type unit for higher flows, where you've got huge compressors, etc. as well. And there's a lot of maintenance on some of those big compressors. So from my point of view, either or, doesn't matter. You can use both for big flows, you can use both for smaller flows. The advantages in either case are the same in terms of CAPEX and OPEX for RO-EDI UF.
Okay, a few more questions that people have logged on here. This is related. It says, is the CDI concentrate recycled? Is there an option for a CO2 membrane degasser so the CO2 does not accumulate within the system instead of using a caustic injection?
Yeah. That was standard. I don't think it's on the flow schematic within the presentation itself. There's an option for a degassing membrane after the RO. So RO, degas, CDI. So it becomes a bit of a cleaner system, so you don't have to use caustic dosing. That's a standard option within the units we supply, and that's all part of the hot water sanitizable cycle as well. So it keeps it control of your microbial growth as well. Yes, so that is included as an option. It's not a problem.
Okay. Here's another question. Is there any difference in daily sanitization cycles or techniques between when comparing distillation and RO-based WFI systems?
I think it depends on your usages, really, in terms of demand profiles. I know in some cases where distillation units operate as stop-start. Some of them include a sort of a hot flush before they provide water into a purified water tank. The difference is with a RO-EDI-UF system is it's continuously running, and when the tank is full, we're still continuously running the water around the RO-EDI-UF back to the tank up front of the RO. And as I said, as part of the sustainability profile on the product we have, we recover that water that's sent to drain when it's in that recycle mode through the system, and we're not throwing water down. So in terms of a water footprint, it's much better, and we also reduce the flow. So if it's a 4 meter cubed an hour unit, during recycle, we turn down the VFD on the pump to 50%, so it's recycling at 2 meter cubed an hour, so you're saving some energy there as well. But the beauty is that when there is demand from the WFI tank, you can make straight into it. You know, the water's ready to go straight. There's no internal sanitization or flushing. The sanitizations on RO-EDI-UFs you can do up to once a week. We recommend at least once a month on the system, whether it be purified or WFI. But that all gets dictated from your microbial checks from PQ, and then you can set your alarm and alert levels for when sanitization should take. But I mean, just to give you an example, I mean, you know, I'm based in the UK, and I get a lot of information from the UK service engineers, and these Orion units are set up to tell you when the flux rate is at specification by 10%. It's like a warning light, like in your car for maintenance. You know, you've got to go in for your service now. We have a warning light. It doesn't stop the system, just tells you you've got to plan in a chemical clean for the RO membrane. In the UK, if the units are regularly hot water sanitized, they never get to that point where the RO units need a clean. Now, that may be just because of the water in the UK and maybe different to other countries, but the hot water sanitization cycles of these membranes definitely help it. And we've done, you know, number of almost 5 years worth of equivalent cycles of doing sanitizations every week, and we have no deterioration in the RO or EDI in terms of quality.
Okay, I know we're a few minutes past our designated time slot here, but one final question before we close out the webinar is, do you have any AFU microbial information from current clients? Can you comment on that at all, Ranj?
I don't at hand, but I mean, as I said, we've been supplying RO-EDI-UF systems for the highly purified water spec, which the European Pharma could be allowed for the last 20 years, and they've all been within spec of that. So, i.e., they all give less than 10 CFU per 100 mil, and all give you less than 0.25 EU per mil in terms of on the outlet of those. I mean, we guarantee, even from the Orion, on the outlet of the Orion unit with a UF, we guarantee less than 0.2 microsiemens in terms of conductivity, less than 100 ppb on TOC, and within the specs of bacteria and endotoxins, i.e. less than 10 per 100 CFU per mil, and less than 0.125 EU per mil on endotoxins, which is well within the spec. So that's what we'll guarantee on the outlet of the RO-EDI-UF system.
Okay. Well, with that, we're going to wrap up the webinar here. Just a reminder to take that quick survey so we could enter you into the Amazon gift card drawing and collect your feedback on how we could improve these future webinars. I'd like to thank Ranj, who spent all the time in preparing and delivering this presentation and sharing all his experience and knowledge about transitioning to cold WFI. It was very valuable. And if you have any questions or concerns, please don't hesitate to reach out. Our website is veoliawatertech.com. My contact information is on the previous screen, and we'll get you to the technical person that you need to talk to. So again, my name is TJ Willits with Veolia Water Technologies, and I thank you for all of your time and joining us, and hope to see you on a future webinar. Take care.
Thank you.